So, without actually getting any real numbers, Kenzie, what's your gross income? Just throw me a number. For a year. $1 million. All right, she makes $1 million. We'll have to ask her why the hell she's here that she makes $1 million. All right, that's your gross. But then you also have your net income. All right, which is what's left over after all those things get taken out. Right? Taxes and union fees and all these things, insurance. So net diffusion is when you watch things diffuse, it is the overall direction that things move. Right? There's a net movement. Most of the stuff goes that way. So that's net diffusion. When you're at equilibrium, there is no net. Because for every one that goes to the left, one's going to go to the right. And one's going to go up and one's going to go down. There's no net movement. Think about migration of animals, right? Everybody, a big herd is moving in one direction. And there's that one little bozo that kind of goes off to the side, right? He's not a part of the net movement. But you always have diffusion. There's always movement. It's just not absolute zero, which you'll get in chemistry. Minus 273.15 degrees. All motion stops. Then when the universe reaches that temperature, we know there's two types of diffusion. They're simple. So whatever it is, it can walk through a cell membrane like a ghost. It needs no help of any kind. All right? And then facilitated, well, reminders of what facilitated means. It means to help. So this is still diffusion, which means higher to lower, no energy, but now it needs help. It's going to need a protein channel of some kind. It's going to need a channel or a transporter. So it'll need a channel or a transporter to get through. And we have some examples to show. So right now, up to this point, anybody have any questions? Got lots of flashcards, lots to practice with, lots of vocabulary in a sense. Good targets for exam questions. All right, so now we look at an example of diffusion. Even before they really should have done is put another glass right here with no drops in it whatsoever. First drop goes in, region of higher, region of lower. So I get the spontaneous movement of dye molecules. We're beginning to spontaneous. See how they're going all different directions, right? There's no thing, but this is net movement, right? They're going from here out to there. So it is a net. But then here, there is no spot that has darker color. It's all uniform, all a nice little light red color. So if you took a sample of any one part of that water, it should all have roughly the same number of dye molecules. They're at an equilibrium. Now if you watch it, you'll see the little things move slowly if you can make them that big. But it's not gonna become clear. They'll remain this color for all eternity, unless the dye breaks down structurally. So it'll never go backwards to this. Mm-hmm. It'll never happen. All right, and facilitated diffusion, well, it is trying to go from regions of higher to regions of lower. So if I were listening to this old guy talk in the front, I would write high areas of glucose, low areas of glucose, so I can reinforce the idea of going from regions of higher to regions of lower. But now glucose is big, and it's polar. Remember the rule, polar things do not easily cross through cell membranes. They're going to need help. And the fact that it's big, it's got two strikes against it, so it's not going to be able to go through your cell membranes. It needs a protein structure. It needs a transporter. One of the more common ones is called GLUT2. There's like 7 different ones out there these days, right? Glue, for what do you think stands for?
Stick together.
Oh, okay, good try. I can totally understand that. How about glucose? Right,
Yes.
glue for glucose, and T might stand for transporter. So glucose transporter type number 2.
It breaks it down.
And that's what you have in your cell membranes to help get glucose into your cells. They're called GLUT2 transporters. They require no energy though. It's like a reaction. And I want you guys to begin thinking about this general rule in biochemistry. So, is glucose a compound? Let's practice that chemistry vocabulary. So what is a compound? Comprised
More
of
than
two
one,
or more
right?
different elements, right? So it's a compound, right? It is a substance, it is a chemical. When chemicals bind to a protein structure, protein structures change their shape, right? This is the rule of biochemistry. It makes things a lot easier to understand. So here's glucose. It lands on the protein structure, causing it to change its shape. We'll use more bigger words later for that. But then it allows glucose to let go and come inside the cell. So it is now literally moving glucose or transporting glucose across the cell membrane. But since it changed its shape by a reflex-like, it requires no energy, no ATP. This is still free in terms of what your cells have to expend. But it is a way I need to get glucose from outside to inside, because glucose is too big and it's too polar to cross that hydrophobic part of the cell's membrane.
So things that are like neutral charge can just go.
And it depends. There's still a size issue to go through.
Okay.
And so that's the other thing to kind of keep in mind. And in most cases, no, it won't happen.
So most things go through the protein in order to get inside.
If there is a protein for it.
Oh.
All right? So let me stress that. This transporter is very dedicated. More dedicated than a Labrador retriever. It only moves glucose. It only moves C6H12O6, nothing else.
GLUT2 does.
Right,
So GLUT2 only moves glucose.
glucose. Any GLUT transporter only moves glucose. That means it won't move an ion, it won't move a fatty acid.
Like glucose, one glucose at a time.
Yes, one glucose at a time. All right, now that we've got diffusion down, now we have to look at the definition of osmosis. And we're going to expand it. You know how in math you have substitution, where you have one variable, but that variable is equal to other things, and so you expand the variable, then stick the whole damn thing up into the equation, and it scares the daylights out of you? Well, this is the actual way to think about osmosis. It is the movement of water from regions of higher concentration into regions of lower concentration. Don't write that down, because if you know what diffusion is, then apply the definition of diffusion inside the definition of osmosis. I know what diffusion is, right? It's the spontaneous movement of a substance from region of higher concentration to region of lower concentration. All right? But what is that substance? Water, and only water. Water is the only thing that goes through osmosis. Nothing else. No ions, no sugars, no fatty acids. So if I know the definition of diffusion, I can think of it like this. The spontaneous movement of water from regions of higher concentration to regions of lower concentration across a selectively permeable membrane. You must add that part to your definition for the full 2 points that this will be worth on your exam. You have to use the word water and across a selectively permeable membrane. Or if you want, a cell membrane. I don't care which you use. But diffusion is only about water crossing cell membranes. That's it. So if I had a glass of water, is there osmosis taking place in this glass? Nope, not at all. Because there's no cell membranes in here. It's only about water across cell membranes. No ifs, ands, or buts about it. It's a hard, rigid rule of definitions. You had a question?
What's selective?
Well, you read my mind. All right, so what does selectively mean? How many of you are selective eaters? All right? Shame on you. You're missing out so much in life. All right? I ask what it is after I swallow it.
Oh, man.
Okay? Because if you tell me what it is, that might curl my stomach and go, there's no way I'm putting that in my mouth. But if you close my eyes and pinch my nose and have me eat it, go, oh, that tastes so doggone good. What is it? Oh, it's puppy eyeballs. Wow, I really like puppy eyeballs then. I wouldn't have thought about it.
Oh, my
Okay?
gosh.
Why puppy eyeballs? Why do you think
Fish eyeballs. Fish eyeballs. They're high in nutrients. Have
She
you ever
said, "Don't
stranded
mess
in
with
a
the
raft?
puppies."
Yeah, eyeballs of fish. Okay. What does permeable refer to?
Not fish eyes.
Permanent?
Not fish eyes.
Permeable.
What is,
Cell.
think about permeable.
Permanent?
Permanent?
Not permanent. Think of another usage, or where you maybe heard something that sounds an awful lot like permeable.
Perms?
Look, I'm like perm.
Something through it, right? What if I said that
Penetrable?
penetrable, or I was at a friend's house and the smell of cooked fish, not cooked puppies, right, permeated my clothes,
Oh.
right?
Perfume.
Like perfume, right, got through. So
Okay.
permeable means like porousness, to be able to cross, to get across, to move through. So we think about permeable as being able to get through, and selectively as fussy, only certain things can, certain things can't, then only certain things can cross a cell membrane.
Mm-hmm.
That's because of its structure, right? Go back to this. Give you guys a second to write that down.
So permeable is being able to get through.
Right. So let's look at our cell membrane here. Can a polar substance cross through the cell membrane?
No.
Nope, not at all, right? Okay. Could glucose cross the cell membrane? Is it a transporter? Yes, it could.
Yeah.
Right? So it's saying, well, sodium, I'm sorry, you can't come in. Glucose, you could if
You have
the
a
right taxi
transporter.
cab.
Yeah.
So it's selective in terms of what can and can't cross, even by its own structure. Right? It's limiting. It's like the bouncer at a club. You have to be the right height, the right look, the right clothes, and give them the right amount of money, right, to get inside.
Yeah, especially in Hollywood.
Osmosis is,
So osmosis then is simply the diffusion of water across a cell's membrane.
Mm-hmm.
But if you expand it to truly understand what it is, then take the word diffusion and just put in that definition of diffusion, and then realize we're only talking about water, not any substance. Because anything can diffuse, but only water can do osmosis.
Osmosis. Only water can do osmosis.
Permeable, I would put a big star next to that and get truly comfortable with that word, permeable. So you're going to come across it a lot in 241 and 242, and how permeableness can change in a cell's membrane. All right, so let's go back to this goofy thing called osmosis. The diffusion of water, which means from regions of higher to regions of lower, across a cell's membrane. All right, so when I'm thinking about diffusion, I need to know where there's high amounts of water and where there's low amounts of water. So I know where there's high, where there's low, therefore which way water will go. Right? I need to know where the concentration gradient is of water.
Because it goes from high to
All
low.
right, that sounds straightforward. And then some cranky person who probably didn't have enough puppies in their life created these three words. Now, these words themselves do not directly talk about the amount of water. They don't. They address the amount of stuff that is dissolved in the water. They address the amount of stuff that is dissolved in the water. So there's two more words you gotta learn. All right? Solvent and solute. Not the word you use when you're drinking. Salute. All right? Solvent. That is the stuff doing the dissolving. That's the liquid doing the dissolving.
Okay, solvent. Then when it's dissolved, it's
So
probably.
let's say I was babysitting a bunch of 8-year-old girls over the weekend, which I was not, but I was a godfather, I was babysitting them. I made the mistake of falling asleep on my recliner, and I woke up and found all my toenails purple, with little smiley faces on them. All right? I'm not about to walk around with smiley faces on my toenails. I want to get rid of it. So I apply nail polish remover to take off the nail polish. Is that nail polish remover dissolving the nail polish?
Mm-hmm.
Therefore, it is a solvent, right? Because it's dissolving the stuff. Water is the universal solvent. Remember, we used that word a while ago, last week, in terms of Water being both an acid and a base. So water is a universal solvent. Imagine a glass of water. Water is a solvent. Now pour in a teaspoon of salt into that glass of water. After a while, it dissolves, right?
Mm-hmm.
So the salt is the solute. That is the stuff being dissolved.
It disappears. Okay.
If you put sugar in your coffee, coffee's the solvent and the sugar is the
Salute.
solute. That is the stuff being dissolved by the solvent.
So,
Therefore, these words are about the concentration of solute. They're about the amount of stuff dissolved in the water, not about the water. So therefore, the word hyper means a high concentration of solute in that solution.
so it'll be like a high amount of sugar in the coffee.
So if you know the amount of solute, it implies, it suggests the amount of water. If you're high in solute, you're low in water. You have a low concentration of water. Because we're talking about the relative comparison between the two, right? This, if we make this room full, well, make the room close, and you guys are all dissolved particles in the liquid. I'm going to be water, you're going to be solutes. There's way more of you than me. So you are hypertonic relative to me. I'm outnumbered. Whichever one has the greater number of gets the word hyper with it. Whichever one has the less amount gets the word hypo. So hypo means a low concentration of solute. Therefore, that tells you, mysteriously, that there's a high amount of water. Keep these words together. We're always talking about the ratio, the combination of solute to solvent. If you're high in solute, you're going to be low in solvent. If you're low in solute, you're going to be high in solute. Because they go hand in hand. All right? If you're iso, then you have an equilibrium. You have the same amount of each thing. Same amount of solute and same amount of solvent.
Okay.
And we're going to watch a little cartoon of this and give some real world applications of this. So keep in mind that when you're dealing with two different environments, maybe a cell in a solution. The solution is one environment, right? So here's a beaker, and it has a bunch of liquid in it. Well, my H2O is my solvent. That is one environment. But then the cell inside of it, remember, it has cytoplasm in it. Cytoplasm is mainly water. So here's my second environment that has water in it. I'm going to compare this environment to that environment. And that will tell me which way water could move. One of these is going to be hypertonic, the other is going to be hypotonic. Alright, so let's do it this way. Yeah. 1 gig of memory storage. So I'm going to try and convert these to be small little files. But if I can't, or just other classes, right? This is the name of the publisher, and they have put lots of things for students to look at in terms of biology. So you do McGraw-Hill, you just do osmosis, and it'll probably bring you to the web page. On the left-hand side, you can go down and see where they have all kinds of cool things that are going to be seen today. So let's see.